See that we've animated these actual landing gears. So here's where you insert the sound effects. There we go. All right. So now if we want to 3D print this, of course you can't 3D print animated objects, but actually you sort of can, because if you were to move those into an exploded view, of course you print it out as pieces, and I think Robert and them will maybe explain a little more about that. But anyways, so now we can actually print those as separate pieces, let's reassemble it, and now we have our animation for our 3D printed model. Okay. All right. So let's see what else can we cover here. I want to briefly talk about sharing. There's numerous formats that we support, and many of the formats support 3D printing directly. So we have all sorts of ways of being able to get to any type of 3D printer that is out there. You can also share. We also have the Sketchfab uploader built into FormZ. That is a site that you can actually give someone an actual web link, and they can access your files. You can have it as a very secure format with a password. You can only give it to who you want to see it. They need a password. You can share it to the whole world if you want, but you can also make it private. Then they can't download the actual model unless you give them permission to actually download. So you have total control of that. And just to show that that is actually built right in, so that all I have to do is choose this option, and your model will be uploaded there. And then you can share the link with someone if you choose, who you actually choose to share it with. And of course, any content out there, since we support so many formats, you can actually import from any resource out there, no matter what the format is, a DWG, DXF, SketchUp, whatever the file is, you can actually bring it in. You can actually import it as a component directly too. You can just import it as an object, or import it into your component libraries. So there's an actual import component button. So it brings it right in, ready to be used. Okay. All right, let's talk a little bit about 3D printing. That seems to be quite a big thing. We have all sorts of tools to help facilitate the 3D printing process. These are all models. They were all done, modeled in FormZ, printed out. Okay. Maybe highlight someone that's doing a lot of really neat 3D printing stuff. Bradley Touchstone does a lot of 3D printing. It was bridge designs. And one thing that I think is sort of cool, he takes his 3D printed model, collages that in the actual scene, and so it's almost like a collaged photograph, but he's using, instead of a rendering, he's using 3D printed models. That's sort of a interesting little thing that's done with that. So that's an actual 3D print, it's not an actual rendering. Just sort of cool collage in the background there. But the thing that I want to talk about is, where does FormZ fit in with the 3D printing workflow? And it's assumed that you take your 3D model, you export it out, the printer reads it in and prints it out. It's done, right? Well, actually, in reality, there's this extra little step that you have to do, and that is you really got to analyze that model and have the tools and features to prep it and fix any irregularities. Now, you can have perfectly clean geometry. FormZ has good industry standard 3D solid geometry, which will print perfect every time. However, if you scale something down, something might get a little too thin. Nothing's wrong with the geometry, it's just that when it goes to the 3D printer, there's something that the 3D printer may not like. So to conform to the standards of the 3D printer, we have a bunch of analysis tools to analyze that model and not only highlight where those problems are, but fix those, okay? And so with those tools, there is a prep tool which analyzes the actual model. You do some live dynamic cross sections before you go to the 3D printer. And you can see there's a long list of things that the print prep tool will look for, okay, and highlight those for you, okay? And with the Object Doctor tool, it'll actually fix a lot of these things. If you want to make sure you have a watertight object, you can just run the Object Doctor on it. It looks for 25 different things, and it'll highlight which things are not good, and it'll attempt to fix those for you. Now, FormZ lets you create anything that you want. It's a solid and a surface modeling program. You can do whatever you want. You can delete faces off of objects and make surfaces. But if you want to 3D print it, now you got to make sure it's a watertight solid. And so, not that there's anything wrong with the geometry. When I say the Object Doctor is going to fix it, it's not that it's bad geometry. It's just it has to be conformed to the 3D printing standards of what the 3D printer wants. And that's what this tool will do for you. Okay. I could walk through some examples if you want to see that. Or look at some other fabrication type processes that can be done through pharmacy, and that is CNC machining. So if you're doing some CNC cutting, maybe I will show a little sample with this one here. I can go back and show some samples of 3D printing if you want to. But in this case, let's say we want to build something like this lattice type structure that we have here, and we want to cut it with a CNC cutter. And so what I'll do is fast forward through the workflow to go from nothing and build the actual model and then cut the CNC cutting and have it ready for the CNC cutting. So let's take a look at that one. Let's see. Let's open up that. All right, first thing I'll do is just take a minute or two and fast forward through the workflow of how you would create something like that. And here's the actual final conceptual model that we have there. And what we did is start off with a 2D rectangle. All right, and we take that rectangle and we convert it into a NURBS object. We just did that previously. Convert to NURBS. We can take those controls and move those around, right? So we can articulate that and move those controls. We can use the thicken tool to give it whatever thickness we want, right? And then we can cut a series of contours. There's an actual contour cut tool. And if I were to click on that object, let's cut it every 6 inches. I click on it, and there, we cut cross sections every 6 inches. Once again, result buffer mode, live dynamic editing of those contour cut parameters. So I can change the distance maybe from 6 to 3. So now I'll have more cuts through there. I can rotate it. So maybe I'll rotate this 90 degrees that way, so we're cutting it along in that direction, or rotate it the other way, go like crazy angles wherever you want. And we can actually lay these flat out here. I mean, I can actually go in and use on XY plane, and it'll actually lay those out flat for us, or we can leave them in the actual position of where they are there. Okay. So as we go through that, we can cut those contours in this direction, cut them in the other direction here. All right. And then what we need to do is cut the actual notches out of there. And so what we do is we use the thicken tool to thicken those 2D cross-section cuts, whatever the thickness of the material is that we're going to actually cut out of. So, and then we can actually do a surface split and cut that thickness out of each of those. And you don't do those one by one. You actually do it in one shot. You actually grab all of them in this direction. You grab all of them in the other direction. You do one surface split operation. It cuts them all in one shot. And so here's looking at a couple of them. We end up with a whole grid that looks like that. Okay? And if you have more questions on that, I can actually show this in more detail later. But I just want to sort of fast forward through. But so here we have all these 2D cross sections that have these notches that are ready for the cutting process. But how do we get those set up so that we can actually lay them out that a CNC machine can understand them? And of course, they all have to be laying flat on a flat XY plane, right? Well, one way to do that is we can actually grab all these. And one thing that you can do is anytime you want to get information about objects, you just grab the objects, you look in tool options, all the stuff is always over here in the tool options palette. One of the things is the information about the object. So I can have all these objects and say, let's rotate them all 90 degrees by the X. So they're all lying flat, like that. I'll move them so that the Z equals 0, and boom, now they're all laying flat on the XY plane here. I have the plane turned off. Turn that on there. There it is. Okay, there you go. Now I want to evenly distribute those or align those. So there's an align and distribute tool right there, and say let's align them all along the Y, and let's give it a distance. Let's say every 1 inch or so. I don't know, spacing like that. So there, we have them all laying flat on the XY plane, and of course to make it a little more efficient for the cutting process, we don't want to use a huge sheet of whatever the material is. Now you're on your own at this point. You got to pretty much move those to where you need them to be. So at this point you can adjust those. Now, one last thing I want to mention about the CNC cutting is CNC cutters are expecting a certain type of geometry. And so you have to conform to what that CNC cutter wants. And so Formsy supports them all. Just to sort of show you, if I were to look at a top view here, you can see that since we started off with NURBS type geometry, it's smooth spline-based data. When we cut our contours, the contours is spline-based mathematical data. Some CNC machines understand that, some of them don't. If you need to convert that to a series of arcs, we have a convert to arcs tool. So all you have to do is use that tool on the object, and we can see the difference between these. If we have a spline, move one spline control, we have sort of a curve that interpolates through there. Whereas this one that's converted to arcs, you can see it's a whole bunch of arcs. So I go in here and show controls. There's the center points for the arcs, and there's one single arc there. CNC cutters may understand just vector data, points, XY points. That cutter head goes here to there to there. It just goes to a bunch of points. So you can take smooth data, convert that to a faceted vector line using the convert tool, convert that. And really the only way to see that if you go into wireframe mode, and I can actually turn on the show points so we can look at the actual points that are there. You can control the distribution number of points there. So you take any shape and say how many points do you want in there. There's two ways of controlling that. One is the display resolution of the object, and the second one is actually we can use the polygon reduction tool. And with that, this is normally used on 3D objects. So you can reduce the number of polygons. You have a very, maybe point cloud data or some very complex meshed object, and you want to have that same form with less polygons. It's usually used in that, but you can also use that on actual line work too. So there's an actual edge type angle, so I can actually reduce and maintain that shape and have a reduced number of edges there. So anyways, that's just some different ways that we can actually work with CNC cutters. Also do some unfolding if you want. Maybe just look at a real quick example of that. Let's bring up a little file. Unfolding. You can unfold pretty much anything you want. Pretty easy to use. All you have to do is find the unfold tool. Here it is right here. Oop. Unfold. And click on the object. There it is, done. We have a few options here. You can generate the connectors. So we can actually give it the size and put some text labels on there, things like that, to sort of, so that when you print it out, you'll be able to know which tab goes with which one. The box is pretty simple, you know where things go, but more complex unfolding operations would require you to put some kind of text information in there, okay? It handles curved objects just as well. So we can go in and unfold. You can see the cylinder, that's one single surface there. If we were to unfold this, unfolds that fine. Now, what about non-developable surfaces, complex, convex, and concave type surfaces? Then what you'll have to do is unfold that. See, it doesn't work. Because you have to compensate for the actual elasticity of the surface and the stretching of the surface, because non-developable multi-curving surfaces have to bend and stretch somewhere to unfold it flat. And so what you can do is actually take and unfold it, and using this option here, you can unfold a faceted representation of that. So now we can actually take that double curving type of geometry and still unfold it as faceted. Okay. So there, handle some pretty complex cases there. So there, if you have some kind of a roof, you can unfold it and print that on your printer and cut it out and do some tape and glue and scissors and make a poor man's little 3D rapid prototype model. All right. All right, what else do we want to talk about? Maybe we'll talk about layout. You can take your 3D designs, quickly lay them out as drafting type documentation. I'll show you how quickly that can be done. So let's try that here. Bring up a little sample file that we can try. Let's see. Let's open up this file. So there we go. We have some type of a design that we want to do some quick conceptual layout type documentation for that to send it out to the lab to be fabbed. Here's how it works. You create a brand new layout, give it whatever paper size you want. All right, and at this point, we're sort of like in a InDesign type document. You know, we can create a bunch of sheets on paper. We can add them, and we get a long list of these pieces of paper, and we can just draw whatever we want on there. We have all the drawing tools. We can put text and dimensions, and we can put images on there and all that stuff. But how do we get our 3D model in there? What we can do is actually create frames. You can create one frame, or you can also create multiple frames, and we can link a 3D model to that frame. So what I'll do with that 3D model that I just opened up, I will add it to my list here. I gotta figure out where I placed it. Here it is right there. There we go. All right, so what do we want? We can have a top view, front view, side view. You can set whatever views that you want. You can have one frame or multiple frames, set your scale, and you just click the OK button, and off it goes. And now what we have is 2D information representing that model inside of our layout space. Done. And we can add some dimensions and things like that to it. Okay? And there it is. So there's an actual floor plan, front view, so on and so forth. All right. If your 3D model changes, of course, your frame information will update also. So just another little added side thing to sort of complement your workflow besides just the 3D modeling aspects. All right. All right. So
Question, sorry.
I'm gonna. Yep. Go ahead.
When you use that layout, can you zoom in and zoom out of a large object like a house like that? The dimensions appear and disappear.
Yes, there is a setting for that.
My question was, say I want a PDF file that I want to just send to a vendor, and they don't have, you know, a reader basically for this. How can they read it? Can it be, you know, exported as a PDF, or
Yes, you can export as a PDF file.
where all the dimensions are visible to the?
Correct. Yeah, when it's a PDF, it's going to take whatever dimensional data, whatever you see on the screen should export out to the PDF file. If you need to control that with a parameter here, when you set up your dimension styles, you can see that in that style, not to create a new one here, there is an option down here to hide those if they get within a certain tolerance range. So make sure you don't have that on, because that helps so that if you're zooming way out, you don't want to see the text there. You only see it if you're close enough to see the actual text. So make sure that that option is not on for that.
Is there a way to save a new style?
Yes, because anytime that you create a brand new style here, that's stored with the project, but you can actually load those dimension styles from some of the projects. So you can have one project that has all of your standard styles, and you can actually load those in here using this load option there. Okay.
I use a template file that has everything preset in it, and then import from that as I need. You know,
Yep,
different
that
settings
is a
for
very
different
good idea.
dimensions and resolution of objects and texture mapping. I mean, lots of different things can be stored in a single file that you can refer, or multiple files if you want different style libraries.
Correct. That is a very good point. In your preferences, you can use a template file. That is a Formsy file that has lights, materials, anything you commonly use, so that every time you launch a brand new project, it comes up with those settings every single time. So, at this point, I think we spent about an hour or so, so I think this is enough to hopefully give you a good overview of all the things you can do with Formsy, with actually stressing more on what our core strength is, which is the 3D modeling end. And so the mixed bag modeler here with the polygon mesh modeling, NURBS modeling, subdivision modeling, smooth ACES space, and parametric modeling. You know, all these different flavors give you advantages of all the best of the different 3D modeling technologies out there combined into one modeling tool. So that's everything I had to show this afternoon. But based on the questions and based on what happens after this, so we definitely have time to cover a lot more stuff. What I would like to do is definitely give some time to the wonderful guests that we have here to show not quite the technical aspect of Formsy of what I was doing, but how they actually use it in the day-to-day production workflow of the work that they do. So at this point, I would like to hand it over to them first, and then after that, I think that would be a good point to open it up for the question and answer session after that.
Quick break while we're restructuring, and everybody, the three of you that are going to demonstrate. For a moment, we can, you know, grab a cup of coffee, use the restroom, whatever, and then we can be set up for Rob and Ollie and John. Perfect.